Hello everyone, and welcome to our presentation on heat transfer. We are Group 13, and today we will be exploring the different methods and mechanism of heat transfer. Table of contents. Here is a brief overview of what we are going to cover today. Introduction of heat transfer, conduction, convection, and radiation. Introduction. Heat transfer is a transfer of thermal energy from one body or system to another due to the temperature difference between the two bodies. There are three main methods of heat transfer, which are conduction, convection, and radiation. Various mechanisms facilitate these methods include diffusion, advection, natural convection, forced convection, and thermal convection.
Conduction. Conduction is a transfer of heat between objects in physical contact with each other. It occurs due to the direct interaction between the atoms or molecules of the two objects, and it can happen in solids, liquids, and gases. How conduction works. When an object is heated, its atoms or molecules vibrate more rapidly. These vibrating molecules or atoms colliding with neighboring atoms or molecule transfers the energy. The energy is transferred through the material, conducting heat away from the source. Characteristics of conduction. Conduction requires direct physical contact between objects. Heat transfer occurs from higher temperature to a lower temperature. Conduction reaches a steady state where temperature gradient remains constant, and conduction is affected by thermal conductivity of the material. Examples of conduction. Holding a hot cup of coffee. Heat conducts from the coffee onto your hand. Metal spoon in a hot soup. Heat conducts from the soup onto the spoon. Heat sink and electronics. Conduction cools the device by transferring heat away. Factors affecting conduction. Thermal conductivity, temperature difference, surface area, and thickness. The equation of amount of heat transferred by conduction is given by K, where K is a constant, by the surface area A, by the temperature difference, or divided by the thickness L. Convection. Convection is the transfer of heat through the movement of fluids, which are gases or liquids. It occurs when the fluid is heated, causing it to expand and become less dense than the surrounding fluid. This creates a circulation of fluid known as convection cell, which allows heat to be transferred. Types of convection. There are two types of convection, natural convection and forced convection. Natural convection occurs due to the temperature differences caused by temperature variations. Example, rising heat from a fire or radiator. Forced convection. It occurs when a fluid is forced to move by an external force, such as a fan or a pump. Example, air conditioning system or heat exchangers. How convection works. A fluid is heated, causing it to expand and become less dense. The heated fluid rises, creating a convection cell. The fluid circulates, carrying heat away from the source. The fluid cools, becoming denser and sinking. Characteristics of convection. In convection, there's fluid motion. In convection, heat transfers through mass transport. Convection depends on fluid properties such as density, viscosity, and specific heat capacity. Convection can be natural or forced. Examples of convection: ocean currents, atmospheric circulation, heating systems such as radiators and heat exchangers, cooling systems such as air conditioning and refrigeration. The equation for heat transfer through convection is given by Q, which is the energy, is equal to H, which is the connective heat transfer coefficient, times the surface area E times the temperature difference between the two bodies. Radiation. Radiation is a transfer of heat through electromagnetic waves such as light and radio waves. It occurs when an object at a higher temperature emits energy in the form of electromagnetic waves, which are then absorbed by an object at a lower temperature. How radiation works. An object at a higher temperature emits electromagnetic waves. The waves travel through space until they reach another object. The waves are absorbed by the object, transferring energy. Characteristics of radiation. No medium is required in radiation. Long-range transfer can occur through radiation. Radiation depends on the temperature and surface properties. Radiation can be both thermal and non-thermal. Examples of radiation. Solar radiation, which is sunlight. Infrared radiation, which is the transfer of heat from a fire or a warm object. Microwave radiation, which is through cooking or heating. Radio wave radiation, which is through communication systems. The equation of heat transferred through radiation is given by Q, which is equal to the transfer rate, is equal to epsilon, which is the emissivity, and sigma, which is the Stefan-Boltzmann constant, all multiplying the difference between the temperature of the emitting object and the temperature of the receiving object.
Importance. Heat transfer is crucial in various aspects of our lives and play a significant role in many industries. Temperature control, energy efficiency, comfort and safety, food processing, medical applications. Electronics, industrial processing, environmental control, material science, and space exploration. In conclusion, understanding heat transfer is essential for various applications in our daily lives and multiple industries. Thank you for your time and attention. We hope you found this presentation informative and engaging.